Okay, hello everyone. There we go. Our third video. Third video. Okay, so we have a ratio. That's what we're going to talk about now. So ratio is kind of a word that we use in everyday language. So hopefully it's not too surprising of a concept, just in general what it means. So a ratio is the relationship between two or more values. So what we're going to be looking at again, of course, is the relationship between numbers. But again, think about it. If I had 4 apples and 5 oranges, that's a ratio. It's the relationship between two or more things. I have for every 4 apples, 5 oranges, or so on and so forth. For every 3 pencils, I have 2 erasers. And, so we can apply it to everyday concept. But again, that's the biggest thing. It's a relationship between two or more values. So we're looking at the relationship of it. Okay. So when it comes to a ratio, it can be expressed in many different ways. So here are the 4 ways we can express it. In the first way, in just written format, so every 4 to 6. Again, for every 4 oranges, you have 6 apples. Or numerically, so 4 to 6. Or we can introduce this colon to represent what the 2 is doing. Or we can also look at a fraction. That is another way to represent a ratio. For every 4, I have 6 parts of a whole. That is another way we can look at it. So 4 different ways. These 4 different ways, specifically the third and fourth, that's going to help us with examples. So now what we're going to be doing are just examples with ratios and slowly introducing more examples with ratios. Okay, so convert the ratio to a fraction or a mixed number. So one thing to remember, that's why you want to stress the above. Well, 3 and 4, they're showing the same thing. So notice if I have every 3 to 4, well then I can look at the fourth representation and say, well, that is 3/4. And please again be careful, order does matter when it comes to ratios. So just notice the 3 comes first, so that will identify the numerator, and then the 4 will come as the denominator. So just be careful, because if we switch it, then we're talking about something else. Okay, 5 to 3. So 5:3. Well, again, I can just write it as the fourth representation, 5/3. But again, this clarifies or a mixed number. Notice this is a fraction greater than 1, so I will have to convert it to a mixed number. So remember, when we convert to a mixed number, we have to ask ourselves, how many times did the denominator go into the numerator? In this case, 3 goes into 5 one time. We have 2 left over, and of course, we use the original denominator, and there is our answer, 1 2/3. Okay, now we're going to be looking, one more example, and then I'll go into a spiel. So convert the fraction to a ratio. Well, again, going back to our different representations, the third and fourth one is super key here. So notice we're given a fraction. So that implies now if we have 18/27, who's going to be on the left side of the colon? 18. And then on the right side of the colon, we have 27. Okay. Now we're going to be looking at examples, again, some more different formatting. So now we're going to be looking at decimals, fractions, ratios, percentages, all that good stuff, all kind of jumbled into one. So convert the ratio to a decimal. So first things first is when you go through these, which is why I recommend having some sort of like study guide or cheat sheet for yourself while helping study, is some of these techniques, you're going to have a middle step that you need. So notice within the first examples, we could kind of just go straight through because of the relationship of fractions and ratios. But when we introduce decimals and percentages into play, you can't just go right through. They're not already with 1 through 4 of the representations. So that is where you're going to have to remember certain middle steps that we need to help us get to the final result that we need. So in this case, if I want to get to a ratio, if I want to go from a ratio to a decimal, I can't just go straight through. I don't know yet. I don't know what this is as a decimal, but what can I do? Well, if I go from a ratio, here, let me write it out, a ratio to a fraction, because we know ratios and fractions are represented similarly, or they mean the same thing. Well, I know then how to do a fraction to a decimal. So those are the middle steps that you need to think of. So sometimes you have to be careful and think, If you can't go straight through, what do I need? And in this case, you need a fraction to help you out. So we can see that 25 colon 2, so 25 to 2, well, that's equal to 25 over 2. And now that we have a fraction, well, I know if I have a fraction, if I want to get to a decimal, that requires some long division. So we're going to go ahead and long divide. Okay, because again, we want to think of our end game, and our end game here is a decimal. So if we see we have 2 on the outside, 25 inside, how many times does 2 go into 2? Well, 2 goes into 2 one time. 2 times 2 gives a 2 times 1 gives a product of 2. Then if we take the difference, we end up getting, wait, oh, 0. Sorry, I got confused for a second. 0. Well, 2 does not go into 0, so I got to pull down this 5. Then we can see 2 goes into 5 2 times. 2 times 2 gives a product of 4. And here we can see, notice we used up all of our numbers. And we can see that 2 goes into 25 12 whole times. But since 25 is not perfectly divisible by 2, we're going to have some spare change. So make sure to put that decimal. So 5 minus 4 then gives a difference of 1. 2 does not go into 1, so I'm going to need a 0 to help me out to get 10. 2 goes into 10 5 times. And 2 times 5 gives a product of 10. So there we go with our remainder of 0, 12.5. So therefore, we have 12.5 as our decimal. Okay, so notice there are some intermediate steps that we will need. Oh, my nose. Sorry, this change in weather is killing me. Okay. Tata, можешь на пишение? Okay, so now let's go the other way. Oh, my nose. Okay, sorry. I know that's super frustrating. My allergies are going crazy. So convert the decimal to a ratio. So yet again, I don't know a clear way of how to go from decimal to ratio. But I know how to go decimal to fraction, and then I know how to do then fraction to ratio. So how do I then do decimal to fraction? Well, notice I don't have a whole number though. So remember in the last video we talked about that you want to multiply by a power of 10 depending on how many decimals you have. So in this case, we're going to multiply by just 10 since we only have one digit after the decimal. So we have 9.8 over 1. That's the number we're looking at. And remember, we want to multiply then the numerator and the denominator. So go back to that note that we had. Oh, actually, I could just pull it up. So remember, if the percent is not a whole number, in this case, don't worry about percent, we're looking at just fraction, is not a whole number, then multiply the numerator and denominator by a power of 10. So notice, or where x represents the amount of decimal places. So notice we have one digit after the decimal place, so we're just going to multiply by 10 to the first, and that's just 10, but we're multiplying the numerator and the denominator. I did make a mistake in last video that I'll clarify in an email. I accidentally put something over 100. I did my multiplication wrong, but this is what we're multiplying by. Okay, and if we multiply 9.8 times 10, I end up getting 98 over 10. So here's our fraction. Well, now that we have a fraction, I can work with a fraction. I know how to get from fraction to ratio. But remember what happens when you have fractions. What do you have to do with fractions? You have to simplify. Well, let's see what numbers 98 and 10 have in common. Well, they're both even numbers. So let's start with that. 98 divided by 2 is 49. So 49 times 2 are the factors of 98. And then we have 5 times 2 as the factors of number 10. So here we can see 2 over 2 is the number that they share in common. That's what they want to factor out because 2 divided by 2 is just 1. So we're left with 49 over 5. Well, now I have my fraction. So from a fraction, I can go ahead and work with a ratio because remember they represent the same thing. So therefore, we have 49 colon 5 as our final answer. So again, you got to think of those intermediate steps. Okay. Now we want to look at ratio to a percentage. Let me move this down a little bit. I feel like I'm going to need more space. Okay. Well, again, and this is what's tricky about this chapter, is again, there's a lot of, you have to remember how to get to certain places. And what do I mean by certain places? From a ratio, can I go straight to a percent? No. Well, what do I know how to do? Well, I know how to go from a ratio to a fraction. Okay, that's a start. Well, from a fraction, what do I know how to do? Well, from a fraction, I know how to get to a decimal. From a decimal, then I know how to get to a percent. So again, you have to recall those little in-between steps, which can sometimes be difficult. So let's look at this guy as a fraction. So 15 to 2 is equal to really just 15 over 2. Because remember the different representations that mean the same thing. Well, now I can long divide. So then I can divide 15 by 2. Well, 2 goes into 15 7 whole times. And the rest is left over because, again, 15 is not perfectly divisible by 2. 2 times 7 is 14. I have a difference of 1. 2 does not go into 1, but I can pull down a 0 to help me out. And we see 2 goes into 10 5 times. 2 times 5 is 10. So there we can see we have a remainder of 0. So 7.5 is the number we want to deal with. So then, notice we're making our way there. So we needed a ratio to a fraction because from a fraction, we can go to a decimal. Well, now I can get to the end game of a percentage from a fraction. Or I'm sorry, oh my gosh, from a decimal. So 7.5. Remember, what do we do for decimal to percent? Well, I have to multiply by 100. And remember what happens when you multiply by 100. It ends up moving the decimal 2 spots to the right. So this empty space I'm going to fill with a 0, add my decimal, and I'm all set. Oh my gosh, or add my percentage. I swear, sometimes my brain just moves too much faster than my mouth. So this is then 750%. And again, if you notice, what are you doing? This is a fraction greater than 1, so we should have a percentage bigger than 100. Okay, last one, percent to a ratio. So again, you have to think of in-between steps. I can't go percent straight to a ratio, but what do I know how to do? Well, I know how to do a percent to a fraction. That's something we talked about in a previous video. And then from a fraction, I know how to make my way to a ratio since they represent the same thing. So that's what we're first going to do, is we're going to take 84% and turn it into a fraction. So remember, what does percent mean? Well, percent means out of 100. So then this implies I have 84 out of 100. So you can think of kind of like an exam if you have 84 correct out of 100. But again, what happens with fractions? You have to simplify. And now this point, once we simplify, we'll have our fraction and we can go straight into a ratio. Well, let's see what 84 and 100 have in common. So in this case, we want to look at their factors. Well, 84 has factors of 21 times 4. And again, they're both even numbers, so you can try with 2. And if you try with 2, you'll see you'll need to go a step further. So again, just work with how much you're comfortable with. In this case, I knew 84 was had factors of 21 and 4, so that's why I could go from there. And 100 has factors of 25 and 4. And notice that 4 over 4, that turns into a 1. Since 4 divided by 4 is 1, it's one of our unique representations of 1. And then we're left with 21 over 25. And 21 over 25, they don't share anything in common, so this is as far as we can go. So therefore, we can finally, from our fraction, get to our ratio using in the beginning of the notes to get 21 to 5. Or, oh my gosh, 21 to 25. And that is it. Again, go through many examples with this. There's some intermediate steps. It can get confusing, but just go step by step and always make sure you're kind of keeping on track the different intermediate steps. Okay, boy.